You step into an elevator and the doors close quietly. The floor number lights up. And for a moment, you are suspended in the air. Above you is empty space. Below you is also empty space. You trust a metal box to carry you safely. Most of the time, you never think about it. But almost everyone has wondered the same thing. What if the elevator falls? This fear feels reasonable. After all, the elevator is hanging by cables. Gravity is always pulling downward. Yet elevator accidents from falling are almost non-existent. This is not luck. It is design. To understand why elevators almost never fall, we must forget movies and focus on how the system is actually built. An elevator is not a box hanging from a rope. It is a balanced machine. Every elevator has a counterweight. This counterweight weighs almost as much as the elevator car itself. When the car goes up, the counterweight goes down. They pull against each other. The motor does not lift the entire weight. It only moves the difference. This makes the system stable and efficient. Now look at the cables. Elevator cables are not thin wires. They are thick steel ropes made of many strands. Each cable alone can hold far more than the elevator ever weighs. And elevators do not rely on one cable. They use several at the same time. Even if one cable failed, the others would still hold the car. But cable failure is not the main safety feature. The real protection comes from something else entirely. It comes from the idea of failing safely. Elevators are designed so that failure triggers stopping, not falling. At the heart of this system is the brake. Elevator brakes are not optional. They are always engaged by default. The motor must actively release them to move the car. If power is lost, the brakes close automatically. The elevator stops. It does not drop. But what if the elevator moves too fast? What if it accelerates downward uncontrollably? This is where the most important device comes in. The governor. The governor is a speed monitor. It constantly measures how fast the elevator is moving. If the elevator exceeds a safe speed, the governor reacts instantly. It triggers mechanical brakes on the elevator car itself. These brakes grip the guide rails. They clamp down with enormous force. The faster the elevator tries to fall, the harder they grip. This is not electronic. It is purely mechanical. No software. No signal delay. Just physics. This system has existed for more than a century. It was invented specifically to stop elevator falls. Even in the worst-case scenario, the elevator does not free fall. It is caught within a very short distance. There is another detail most people never notice. Elevator guide rails are not just for alignment. They are designed to be strong enough to absorb force. The car is not floating freely. It is locked into a vertical track. This track controls motion at all times. Even the bottom of the elevator shaft is designed for safety. There are buffers. These are shock-absorbing systems. If an elevator ever reached the bottom unexpectedly, the buffers absorb energy. They slow the car down. They reduce impact. Once again, the system assumes something might go wrong and prepares for it. This philosophy runs through every part of elevator design. Redundancy, mechanical simplicity, fail-safe behavior. Elevators are inspected regularly. Their components are overbuilt. They are tested far beyond normal conditions. Most elevator incidents are not about falling. They are about doors, or leveling issues, or brief stops. The dramatic fear of falling is mostly a myth. Movies show elevators snapping cables and plummeting. Reality is far less exciting, and far more engineered. An elevator is one of the safest machines you will ever use, because it does not rely on perfection. It relies on preparation. It assumes mistakes will happen, and it designs around them. This reveals something important about good engineering. Safety is not created by strength alone. It is created by systems that expect failure. The elevator does not trust a single component. It trusts layers. Each layer watches the others. Each layer is ready to stop everything. That is why elevators almost never fall. Not because they are strong, but because they are cautious.